Welcome to Introduction to Kotlin and Android App Development. My name is Maximiliano Fertman. I can go by Max. I know it's a long name. And we have a full day creating an app on Android. So we're going to learn Kotlin and also a little bit about Android app development. So we're going to be building an app today. Really quickly, I'm a mobile web developer, so I have been doing websites and web app with HTML, CSS, JavaScript, and all the other technologies since 1995, end of 1995. And also I have started doing mobile apps in around 2001. So that's, of course, before the Android existed. So I did Java on Nokia devices, Symbian, Blackberries, and many other of these old phones. And then I have started doing iOS applications and, of course, Android applications. So I've been doing that for a lot. I'm from Argentina. I'm actually living there in Buenos Aires. In terms of my Android experience, I have published around 20 apps, mostly for customers, so not on my name. So I've been doing consulting and creating apps for those companies. I have started doing Android-specific Java development in 2012, so 10 years ago. So on Kotlin, when actually first started in the market, maybe a few months after that, in 2019. That's all that I have for you at this point in terms of who I am. It's time to start. So we're going to cover today the basics of Kotlin. Kotlin, by the way, it's the language that we're going to use. It's kind of a new language compared with other languages that we have in the market. It appeared in the past 5 years. And you're going to see Android Studio. In fact, one of the requirements for this workshop is for you to install Android Studio. So you can go and do that right now. It's a free tool available for Windows, Mac, and Linux. So we're going to see how to test and debug our Android applications. You don't need a phone or a tablet. So if you don't have an Android phone, it's OK. We will be able to use the emulators as well. We are going to talk and design our app with a framework, a library, known as Jetpack Compose. It's actually a new UI framework, a new UI toolkit from the Android team. So it's actually one of the official ways that we have to create Android applications. So we're going to see how to navigate between screens using this framework, how to work with data, so how to create a data model, and how to connect with web services. So we have a web service. I'm going to download some data from there. And then we will have also a way to communicate that app with a web app. So if you have a website or a web app, you will be able to communicate your Android native application with that web app. So there is a way to render web apps within an Android application and also to bridge Kotlin with JavaScript. So you can execute Kotlin from JavaScript and vice versa. So that's the idea for today. By the way, also there you have the slides, a copy of the slides, and also an assets.zip file that is actually in the public folder in the repository. I will show you that later, where you have some, let's say, SVG files, PNG files, and some other files that we are going to use later in our app. Okay, so the assets folder. And in terms of your experience, if you have experience with any OOP language, so object-oriented programming language, you're OK. I mean, if you're a JavaScript developer, a Java developer, that's good enough. With that, you're ready to start working with Kotlin and Android app development. Let's try to understand where we are today in the front-end map. So that is, we are here at Frontend Masters, so we are frontenders. And today, when you're doing front-end, you have like two main universes. You can make native clients, or you can make web apps, websites, or PWAs, progressive web apps. Today, we're going to focus on native clients. So we're going to create a native client for a platform. when you decide to go with native clients, today you can pick using official SDKs from each platform or cross-platform SDKs. And today we will focus on official SDKs. Here, there are many platforms. There are more than 3, but just the main 3 ones: Android, Apple platforms, and Windows. Today we will focus on Android. You knew that. And then here on the Android official SDK world, you can pick today different languages that you can use. You can use Java, Kotlin, or C and C++. And today we will be focusing on Kotlin. Actually, most of the apps that are written today or starting today are using Kotlin. Okay, so of course you can also mix within one particular project. You can have some parts in Java, some parts in Kotlin, and some parts in Z. Okay, so you can actually mix all these technologies in the same project. But we will be focused in Kotlin. And in terms of the user interface, even if you pick Kotlin, you have several ways to design your application in terms of how you build the user interface. We have something that it's actually unnamed, so we don't have a name for that, but typically it's known as the classic XML user interface. So Android development from the beginning was actually heavily based in XML files, layout files. That's the classic XML system. We have XML with Jetpack. That's something that appeared in the past few years also, because that classic XML system was sometimes a little problematic. So the Android team created a set of libraries known as Jetpack to help with that. And then we have Jetpack Compose. That is actually under that Jetpack umbrella, but it's something completely new. There are no XML files here. So today we're going to be focusing there on Jetpack Compose. That is kind of the I don't want to say the current way to do Android apps, because it's up to you if you want to use them. It's still new. It's still a new UI toolkit. So not every app today is actually using it. But it's becoming stable enough to start working with it. And some companies are starting using it to create their own apps. And fortunately for us, Jetpack Compose, compared with the other UI toolkits, it's actually simpler and let us make an app in one day. Before Jetpack Compose, I would say that it was kind of impossible to actually learn Kotlin and how to actually build an app in just one day. So that's our route, that's our map, okay? So Kotlin, Android, Jetpack Compose. Those are the 3 main topics that we're going to cover today. So we are going to be building one app. It's called Coffee Masters. The idea of the app is that we have a coffee shop, okay, for Frontend Masters, and we're going to make the app so you can actually see the menu and you can order from there. That's kind of the main deal of the app, okay? So we are going to build this app from scratch. So in the repository, you have the steps, step by step, but I'm going to be building that manually directly in Android Studio. So we're going to learn also how to use Android Studio and how that works. So it's for a coffee store. We're going to use Jetpack Compose. And another important decision that we need to make, but actually I already made that decision, is that in terms of the user interface today, you can decide to create your own UI, your own design, or you can use the patterns, the design pattern from the OS. Okay, for example, if you take TikTok, the TikTok application is actually the same on iOS, on Android, and even on the web. So they have their own TikTok user interface, their own custom user interface. They're not following directly the guidelines from each OS. We are going to use material design. Material design is a set of best practices and even some controls, some components, UI components, that we can use on Android. It's open source, and actually you can actually use it on the web, material design, and also on iOS if you want. But we are going to be using some of the ideas and guidelines from the material design system. And as I mentioned before, for the project you will need to download the assets and that are actually in the repository, okay? Because we have the icons, some images, some logos that we're going to use. So we have a question on the chat regarding picking frameworks like this that are like official framework versus cross-platform development, such as, I don't know, Xamarin or React Native. So which one to use? I think that the answer, there is no single answer. I think that it depends on the project. So there are projects that are suitable for cross-platform solutions, such as Flutter, React Native, NativeScript, Microsoft Xamarin. And for other projects, it's maybe a better idea to use native SDKs, or let's say official SDKs from the publishers, such as Jetpack Compose on Android or Swift UI on iOS. So there are advantages and challenges on every decision you make. But I don't think there is a single answer. When someone asks me, are you using always this or always that? My answer is typically it depends on the app, because there are some apps that when you get into the cross-platform idea, you are getting into trouble or a lot of effort. And for some apps, it's pretty good. So I think it depends on the app, and there are so many variables in that decision that it's difficult to give you a straight answer, okay, on which one is better. So it depends on the case. The good thing about learning these things is that, okay, you can like see this yourself or by yourself, and then make your decision on every project on which one do you think fits better. I don't want to get too theoretical here, but something that is important for you to understand is that Android is an open source project, and it's an open source operating system. And actually, when we are building apps for Android, sometimes we are building for the AOSP. AOSP stands from Android Open Source Project. That's AOSP, Android Open Source Project. But on top of that, most of the phones that we own these days, they have another layer known as GMS. That's Google Mobile Services. And not everything that we are used to as Android users is actually open source. For example, Google Maps is not in the open source layer. So the same with Play services, such as the Play Store, but also some services that the OS is offering to apps, such as, for example, geolocation using Wi-Fi. So those services are not available in the open source project. And some vendors, such as Samsung, some manufacturers, are also adding some layers on top of that. For example, if you want to support the Samsung Pen, or if you want to support foldables at some points that are not part of the Android open source project, they have libraries. They're offering for you libraries that you can use for those devices only. I'm mentioning this because there are some devices out there without the GMS layer. Okay? So it's not, I mean, in terms of market share, it's probably 5% or less than 5%. But for example, we have there, some examples are Fire OS. That's the OS actually available on Amazon devices. That can be the Fire tablet and also the Fire Stick that you can, or Fire TV that you can connect to your TV. Also Huawei devices, Huawei phones, so they don't have the Google layer. Meaning that when you're building your app, you need to be very careful when you're using some APIs and libraries, because those libraries might not be available on all the phones. If you're using libraries from the AOSP layer, you're good. You're good to go everywhere. But sometimes you need to be very careful because some libraries won't be available. Okay? For all the topics that we are going to cover today, we are going to be working with the AOSP. So our app will actually work everywhere. But have in mind, when you start adding more libraries and you're starting using services from the operating system, that they might not be available for all your users. In those cases, you need to find, for example, Huawei, it has like an alternative map provider that is part of their vendor software. But yeah, then you need to start doing some conditionals in your app. Okay, if it's a Huawei device, I need to use the Huawei map. If it's not, I need to use the Google Map service. Okay, something like that. One of the problems of Android is that diagram. It's device fragmentation. This is actually from a couple of years ago, so today it's even worse. Every rectangle that you see there is actually a different phone, a different device that is actually active in the market. So we have so many devices from so many different vendors with so many different characteristics that creating an Android application seems a problem, mostly for testing. And that's why using a UI framework that is flexible and can adjust to different scenarios is actually a good idea. Compare this with iOS app development. This is much worse. On iOS, we have 3, 4, 5 different iPhones and maybe some iPads, and that's all. So if you want to test our application, you just need to test on a couple of screen sizes. But here, we have hundreds of different possibilities. So Android app development has these challenges. So talking about Android with Kotlin, we're going to be building APKs. So that's actually our output. An APK is an Android package. The Android package is just a zip file that will include your compile VM code. We're going to talk about that VM in a minute. So your compile code from Kotlin, metadata in different formats. There are a couple of XMLs and some other things there. Assets, I mean PNG files and other formats that we will see later. A signature, because we are going to sign an APK. And it's going to be installable, that APK, via the Play Store or other app stores. And today, the Play Store, since the beginning of 2022, doesn't support APKs anymore. So we have APK, that's the output of our building solution. But actually, the Play Store will need another file. It's called AAB, Android App Bundle. At the end of today's workshop, we're going to see how to build both. Okay? So the APK is actually the actual format that the phone is going to take, but the Play Store needs another format. It's called AAB, and then the Play Store will build the final APK for your users. That's kind of the idea. You can also publish or distribute your app through enterprise solutions. So if you're working for a company and the company has some portals or system like enterprise solutions where they can actually ship the app to their employees without actually going to the public app store. And also you can install your APK in a device through a USB. We're going to see how to connect your phone in case you have one in Android Studio, or other method. I mean, I can publish the APK on a website. I can create my own app store or things like that. Okay. So to actually make that happen, your users need to disable some security rules on the phone to install an APK from untrusted sources, but it's technically possible. Okay. So that's what we're going to build. That's the output of our project when we're building Android apps, not matter the framework or the language that you're using. Before actually writing some Kotlin code and creating an app, we need to discuss a little bit about Android versioning. So today, Android goes from version 1, the first one, to version 13. Of course, we might have the latest version still in beta or in developer preview, but that's roughly how it works. And today, at least, we tend to have one major number per year of the operating system. We used to have code names. Probably you have heard about this, like Froyo, gingerbread, ice cream sandwich. Like every Android version used to have a dessert name. Then names were deprecated from version 10 to kind of 12, but they're still there. And even today, it seems like they're coming back. So these names. But this is just a code name, and it's actually not so important for us. Actually, the version number, the one that says 12.1, it's also not important to us developers. Okay, we will care about something known as the API number, also known as the SDK number. That's what we care about. This is actually an integer, a consecutive integer that express the current version of the API. Every time there is a new Android version changing the API, so they have more things, less things, they have renamed some, methods or classes, they have a new number. Sometimes they release a new Android version, but they don't change the API. So for now, for us, it's just the same in that case. It's just I'm building for API 32. I don't care if it's 12 or 12.1 or 12.1.3. It's just the same. Okay, so we are going to care about the API number. Just remember that we are going to see the API number a couple of times during app development. So we won't see the code name. We won't see the let's say the end user version number. We will talk about the API number. And to make things more complicated for us, every app contains 3 different API definitions or API declarations. We have the minimum SDK version that defines installability. That means when we are building an APK, an Android application, we will pick the minimum API number that we're going to support. So I can say my app is compatible from API 15. So in that case, you're making yourself responsible of using APIs only available in version 15, or if you're using like an API that is only available on later versions, you have a conditional that won't execute those APIs on all the devices. Because if not, the app will crash. I mean, if you try to use an API that is not on the phone, the app will crash. We don't want that, okay? By the way, if your app crashes, it will reduce some kind of a score within the Play Store if your app is published in the Play Store, okay? So it's important to reduce the amount of crashes and bugs because that improves some kind of, it's like SEO, search engine optimization, so it improves your ranking in the Play Store. So we don't want crashes. Crashes happen, but we need to monitor crashes and solve them. So that's the first definition that we need to make, okay? The minimum SDK version. Then we have the target SDK version. That at first it's a little weird to follow, but let me tell you this. It's actually the version of the API or the SDK that you tested your app on. So you're making sure that, I mean, right now let's say that we are building with API 30. That means that we are testing our app in API 30, and we are telling the OS that with API 30, my app works okay. Because what happens in the future when we have API 40? Well, I don't know what will happen today in the future. So I want to let the OS know that this was working fine on 30. And it changes behavior. For example, let's say that foldable phones were not part of the Android SDK until API 30. Okay, so if we compile the app with the target 28, that means we didn't know about foldables at the time. So we are not foldable compatible. So even if you run your app on a foldable device, the phone will know that your app is not compatible with the idea of a foldable. Okay? With that in mind, the OS will change behavior. For example, it won't offer the app the ability to split the screen in 2 halves or something like that. Okay, if you are defining your target from a minimum SDK that supports foldables, the OS will expect you to know how to deal with that. Think about the future. Let's say that in Android, in the SDK 40, they will support holograms. Okay, but we are building the app today. We don't know about holograms or how to render holographics UIs. Well, because we are building and setting the target SDK as 32, the holographic OS will know that we are not holographic compatible, so they will render our app in some kind of a 2D emulator, okay, something like that. Okay, does it make sense? And finally, we have the compiler. So this is actually not shipping with the app, that definition. It's just a compiler that we are using. The more modern the compiler, typically the more efficient and the better output that we have. And typically we use the latest available. Unless there is a bug or something special that we need to, where we need to use an older compiler, we are going to use the latest available. Okay, so these are decisions that we need to make every time we make an app. Okay, and we will see in a minute where we're going to make those definitions. Okay, typically this is the relationship between these SDK. So the compiler is the latest one. The target SDK, most of the time, you use the same one as the compiler. So most of the time, they are the same. And the minimum SDKs, it typically goes back to the past. And I will tell you why in a minute. Okay? In fact, before moving on with some more slides, I have a couple of more slides, and then we will jump directly into Kotlin code. I'm going to open Android Studio. You don't need to follow me at this point. I'm going to create a new project just to show you something really quick. When you create a new project, it doesn't matter what I'm picking here. It's not the important part. I want to show you this. When we are building the app, when we are creating the project, I can pick here the minimum SDK. Okay? So it's actually it's suggesting me to start with API 21. API 21 is Android 5.0. And why picking the minimum SDK is important? Maybe you're saying, hey, why you don't start with API 1? I want to be compatible with everyone. The problem is that the farther you go back, the less APIs you have available. Okay? And here we have a link that says help me choose. If you click there, you have this nice diagram that will tell you, based on the current active users, how many users are going to be covering if you set that as a minimum. So if I set API 21 as my minimum, it's 98% of the Android users out there. That means there are still 2% with Android 4. Okay, that's 8 years ago. So there are still 8-year-old devices out there in the market. But if you pick 28, okay, you are losing 30% or more than 30% of your users. So they won't be able to install your app if you set that as your minimum. Okay, so this is a decision that you need to make. Of course, the more versions that you are covering, that means more testing as well, more UI testing, because you need to make sure that all the users in all those versions are using your app properly, and the app is working properly on their devices. Do you have any question at this point? Yeah.
So are you making a prediction that holographic UI will be available in 40?
I don't know, maybe, yeah, maybe. Or maybe AR. I mean, you put your glasses and the app will pop up in 3D in the environment. I mean, that can happen in the next few years, but yeah. The thing is that when we are working with the app, we need to understand that our app will be compatible. So Android tries to be always future-proof. And with that in mind, if you're building your app today and you're selecting the target with today's maximum target, future Android devices will know that, and they will do their best to actually make your app work great, even in future hardware. So that's kind of the idea, right? That we are going to, I mean, there is no guarantee, but it's kind of they're trying to push this idea of future-proof. That if, I mean, in the Play Store, there are still a lot of apps out in the Play Store that were built 10 years ago. And you're still downloading the same APK. And the idea is that even if you run this in a high-resolution, foldable device, the app should work fine. And Android will try to match whatever expectation you had as a developer 10 years ago. That's kind of idea. Okay? Make sense? Okay. So just have in mind that those are decisions that we need to make. Okay? So in terms of APIs available, as we mentioned before, every new version of the Android operating system includes new API. API to Bluetooth, to use wherever new technology is available. It may have to do with something software-based, like a new background service in the OS, or hardware-based. The latest big sample is foldable devices. Okay, the ability to support more than one screen, or a screen that can fold itself and detect the events. Well, that's one of the latest big additions on Android. If we target users on that new version, it will take years to get to the majority of users. So if I'm building my app using target API 32, the latest one, it's today 0% of the users, 0.5 probably. And it will take years to actually get 50%. Okay? So because this is a problem, because I want to use the latest technologies, but also I need to support all my users out there. Okay? So Google created, the Android team created something known as support libraries. A support library is a framework, okay, so that we need to import and add in our code that will let us use latest abilities with some kind of emulation or polyfill on older devices. Okay? Because if not, I'm always stuck with old APIs. Okay, does it make sense? So it's like on the web when you're using polyfills to fill a gap in a browser that is not supporting an API, something like that. Well, these support libraries today were renamed under the Jetpack name. So Jetpack is actually a set of libraries that are adding support libraries and many other things. So when we hear about Jetpack, it's just this set of libraries. It's a backpack. In fact, the logo of Jetpack is an Android little guy with a backpack. So it's the set of tools that we actually need to create an app. Okay. And in terms of code architecture, the official SDK, the one that we are using, is based on a Java built-on machine, and it's pure written in Java. So, I don't know, let's say the official SDK means the button, the geolocation service, the service that goes to the network. Every API that we are using from the OS is written in Java and runs in a Java built-on machine, in a Java VM. Okay? But it's not the Oracle's or the Sun built-on machine. It has its own engine. In fact, they went to a legal fight, Oracle and Google, because of this. Okay? And so we write Java, we compile Java, but then it's not actually going to Java intermediate language. And there is no Java built-on machine on the Android phone as we know it. It's a different built-on machine. And it's called Dalvik and ART. There we have two runtimes. The original was called Dalvik, it doesn't matter, and the other one is Android runtime. Again, it doesn't matter about the names, but in case you heard about those names, these are the runtimes that are executing Dalvik code. What's Dalvik code? So let's say if you write Java, and now we will talk about Kotlin as well. If you write Java, we compile Java into Java intermediate language, and that intermediate language is compiled into Dalvik executable code. And that's like an Android format. And then the VM will run that Dalvik executable code. So we don't compile native code.
এই করলে ভালো হয় যদি জাভা শেখা যায় তো বুঝছেন সুদীপ তাহলে ভালো হইতো মূলত অ্যান্ড্রয়েড অ্যাপ যদি ডিকম্পাইল করে তাহলে জাভা কোড পাওয়া যায় বুঝলে তো মডিফাই করার জন্য অ্যাপ্লিকেশন তাহলে জাভাটা ভালোই হইতো
on Android, unless we are using C, okay, and that's known as the NDK, the native development kit. But we are using the SDK, and with the SDK, we don't use C, we use Java or Kotlin, and in that case, we don't write native code. We actually write Dalvik executable code. This is transparent to us developers, but I want you to know how that works, because when you have a problem, it will talk about the dex file, and you don't know what the dex file is. Dex is Dalvik executable. So we compile to Java bytecode that has garbage collector like Java, and here comes Kotlin. Kotlin also compiles to Java bytecode. So we are going to write Kotlin, and the Kotlin code that we're going to write is going to be compiled into Java, into Dalvik executable code. That is the same as if we're building Java. In fact, probably you know that you can, on executables, you can actually decompile executables. Okay, you need to see if it's legal in your country and in some situations, but you can decompile code. When you decompile Kotlin applications, you originally get Java. because it's the same intermediate language. It's like .NET with C Sharp and Visual Basic, that they were both compiled into .NET intermediate language. Well, this is the same. We have Java on Android, we have Kotlin on Android. Both are compiled into the same built-on machine code. So they are 100% interoperable because it's just the same. So that's up to the basics of the Android operating system and the architecture of our apps. But let's jump directly into code, into Kotlin code. So Kotlin it's a language created by JetBrains. I'm not sure if you have heard about JetBrains. JetBrains is a company that originally was building IDEs. They have a lot of IDEs available. Let's jump quickly into the JetBrains. Website where you can see all the IDEs that they have. They have IDEs for JavaScript or .NET. That's IntelliJ, WebStorm, PyCharm, PHP Storm, ReSharper, Rider, blah, 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 blah. All these IDEs are actually by JetBrains. And by the way, Android Studio is by JetBrains as well. It's an IDE built by JetBrains that Google licensed to JetBrains so we can use it for free. But actually, Android Studio is a JetBrains IDE, okay, that we can get for free. So Kotlin, the language, was also created by JetBrains. It's open source, and that's why Google or the Android team has decided to use it on Android. Why? Because originally the SDK was only available with Java, and actually the SDK is stacked with Java 6 and some things on Java 8, not even Java 8 completely. So it was an old version of Java, and it was actually complicated to actually evolve Java for Android, mostly with a legal fight between Oracle and Google. So that's why the Android team decided to add an alternative that is modern and faster, that it's compatible with Java built on machine and Android, and that's Kotlin. Okay? It's an statically typed language, so every variable will have a type, but it also contains or supports type inference. So every variable will have a type declaration, like Java, but sometimes we don't need to declare it. And the compiler will just infer the type from the value that we're assigning. So at some point, it looks like JavaScript most of the time. Okay? It's multi-platform. So even we are going to support only today Kotlin for Android. But actually Kotlin also compiles to Java built on machine for backend. So Java Enterprise. Or Kotlin can also compile into other platforms, even the web. I will get into that in a minute. It's easy to learn. We can learn most of Kotlin in just half a day that we're going to do today. Yeah, of course, there are some advanced topics and ideas and design patterns that we won't have time to cover, but most of the language can be covered easily in half a day if you have experience in other modern languages, including JavaScript. So it has less ceremonial compared with Java. I mean, on Java, you need to create listeners, and for listeners, you need to create anonymous classes with a listener inside, just for an on-click handler. And with this, the idea is to be less ceremonial, with less bureaucracy. Okay, let's go and jump directly into code that looks nice. It has some modern ideas in terms of what we can do. Here we have a big warning. Kotlin included a lot of smart ideas that sometimes are not available for Android app development. So you will find, not today, but later when we get with more Kotlin app development, you can get into some architectural ideas, some changes that are not working on Android. Why? Because on Android we have a constraint. That's the Java virtual machine or the Dalvik executable virtual machine that they call Android runtime. And yeah, we are not changing that runtime. Okay, so there are some limitations on the runtime that when you're building Kotlin for other platforms, you don't have. And it includes null safety, the same as other modern languages such as Dart or Swift, and we'll get into that in a minute. We have interpreted languages, where we ship source code, intermediate language, that where we ship bytecode when we compile, and compiled languages that we're going to ship machine code. You can see that Kotlin is actually compatible with bytecode and machine code. So with Kotlin, we can actually build libraries of code or apps that are for Intel's 64 bits or for ARM. So we can actually ship binary code. But for Android, we will focus only here on bytecode because we are going to create code that will work in the Android SDK, in the Android runtime. Okay? But have in mind that Kotlin is available for other platforms. So Kotlin can compile to JVM version 6, to JVM version 8, to Android, Java Dalvik executable, that's the one that we are going to use, to JavaScript, look at that. So we have some kind of a transpiler available that we can write Kotlin and compile that into JavaScript for the web. Also, we can compile native code for iOS, macOS, Android, Windows, Linux, and even WebAssembly. WebAssembly is for then run this in JavaScript. In this case, when we are talking about native in Android, so what's the difference between this Android and the other Android? Is that that's actually for libraries, not for working with the user interface. I mean, you have a cryptographic library or a database library. You can build that in native Kotlin. It ships as a native library that is more performant than the intermediate language, than the VM. And also multi-platform, so you can actually share the same database that you have just created with iOS or macOS or Windows. And just to finish this introduction to the Kotlin idea, there is something that I want you to know that exists, and it's not what we are going to use today. It's called Kotlin Multi-Platform Mobile, KMM. KMM. Kotlin Multi-Platform Mobile is another framework that lets you use Kotlin to create libraries that you can use then on Android and iOS. Okay? Not user interface, not user interfaces, just libraries. Okay? So your business logic, it can be your models, your view models. You can build that in Kotlin and then use that in a normal Kotlin Android project or in a Swift project on iOS. Okay? That's known as Kotlin Multi-Platform Mobile. We are close to see some code, but before doing that, let me show you this diagram really quickly. So this is the current Android app development ecosystem. You have Kotlin Java code that can use Android Jetpack libraries, and those libraries can actually talk to your Android SDK. So we are going to write Kotlin code, right? So our Kotlin code can use Jetpack and also can use directly the APIs from the SDK. Also, you can write your own C++ code and connect them through something known as Java Native Interface. It doesn't matter. So this is the ecosystem. Okay, what we're going to write is just Kotlin and maybe C++. Not today, okay, but on another project you can also write C++. Today we're going to just write Kotlin. The rest is just part of the build or part of the operating system. It's not our code, okay? And our code will be just Kotlin today from that ecosystem. But that just have in mind that that code can talk to C++, they can talk to Jetpack libraries, and also they can talk to the Android SDK APIs. So I don't know, if you want to use Bluetooth API, well, that's part of the Android SDK. You can talk to that API. And in the APK file, so when you're building the app, it will go Dex code. Dex is Dalvik executable. Oops. So Dex is Dalvik executable. And also Jetpack, because Jetpack is not part of the operating system. Jetpack is a library that we are deciding to use. Okay, it's from the Android team, so it's kind of an official library, but it's still a library. So that means that in your APK, the compiled code of Jetpack will also be shipped in the package. And if you have C++ code, you will have the libraries compiled. So we have a question on installing Android Studio and problems with one of the utilities that's called Haxum. So that's actually an emulator, let's say, improver. So it's a tool that will improve performance of your emulator on Intel processors. If you have problems installing, you need to read like the message that you have. Typically, it has to do. Your computer is not Intel compatible for VM acceleration, and sometimes you need to get into the BIOS of your computer and enable virtualization. So if that tool is not working, it shouldn't be a big deal. The only problem is that your emulator will work slower, okay? Because it's not actually running directly into your CPU. The emulator is a VM, so it will convert ARM to Intel, and it's actually slower. It's time to write some Kotlin code. So in the repository, there is a public folder, and in that folder, we have assets. Okay, it's a zip file. If you unzip the file, you will get some PNG that we will use in a couple of minutes, and also you will get into a Kotlin 101 folder. What we're going to do now is to open Android Studio into that folder. It's not actually an Android project. This is actually a couple of files with the extension KTS. By the way, Kotlin files are KT files. KTS, what's that? The S is from Scratch. A Kotlin Scratch file. What's a Scratch file? It's actually a file to play with Kotlin without actually making an app. Okay, that's kind of the idea. You can open that, by the way, if you want in VS Code or any other IDE that you want. In this example only. For Android development, we will actually need Android Studio. But for these files, you can open this in Android Studio if you want, just to see and play with Kotlin. In Android Studio, you can open, and then you go directly into the folder. In this case, I have it into Assets, Android, Kotlin 101. It will look like this. So you have a list of files, and then with the tip of the day that I don't want, and then the code on the other side. So here we're going to just see some code, and also if you want, you can run Kotlin code. That is like a playground. It's a place to play with Kotlin without actually making an app. Okay. So basic expressions. Kotlin code looks like JavaScript or any modern language when you first see it. So if I throw you some Kotlin code, you will understand most of it without even doing any explanation. So I will just jump directly into the differences and really quickly over the things that are usual or similar to other languages. So Kotlin looks like any other language. For example, semicolons. Semicolons are there, but they are optional. And I can say that 99% of the time, you're not going to use semicolons. You use semicolons only when you have two expressions, two sentences in the same line, and that's not something you want to do, actually. Okay? So you create variables, as you can see really quickly, with var. So that's actually pretty straightforward, as with JavaScript. We will get into data types and all that stuff in a minute. Boolean conditions, they need parentheses. So for example, if you're coming from other languages, Python, Ruby, Swift, here have in mind that this is like JavaScript or C or other C-based or C syntax languages. You need parentheses on if, on whiles, on fors. Print and print line. Print will send a message to the console. Print line will send a message and create a new line. One big important thing here, when we are using print to talk to the console is not the phone. Okay, the console is an invisible part of your app, of the operating system. And Android does not support printing without a new line. So actually, when you do print, it goes to a buffer until you do at least one print line. When you do the last print line, you will see that on the screen, meaning that if you are sending print messages, you are not going to see those messages in the console until you send a new line character or a print line. Okay, have that in mind. When you're doing console Kotlin applications, you can use print and it works. Okay, but on Android, we are running on a different operating system with its own rules. So in terms of style guidelines, variable, function, and package names are using camel case. What's a package? Similar to Java package or similar to namespaces in .NET or PHP. It's a way to group code under a name. Okay, all of them are using camel case. So we start with lowercase and then we go uppercase. You know the deal. Constant names, okay, they're using upper snake case. That is, for example, this one, max length. We will talk about this in a minute, like const pal, what is that? No worry for that. And data types, they use title case, as in JavaScript, Java, and many other things, like a class, an object that we don't know what that is yet, but let's say that it's a type, interfaces, also objects that are representing singletons, we tend to use also title case, so we start with uppercase. These are just guidelines. Of course, no one is going to enforce you these ideas, okay, just guidelines. Something interesting is that conditionals are expressions. So you can call a function and put an if inside the function. Okay? And this is different to other languages. Probably you are used to, like, I don't know, less than 2. Else, more or equals to 2. Something like that. This is perfectly valid in Kotlin. So this is actually replacing the ternary operator that probably you are used to. The ternary operator is not available here. You need to use if instead. It's just that. It's just a ternary operator with a different syntax. Okay, makes sense? We don't have a switch, but we do have a when that it's acting like the switch. Okay, and it's even more powerful. We use when and then different cases. On each case, we use this one known as the thin arrow, dash and greater than. And we can have one line, we can have a code block, and there is no need for a break. Okay, there is an automatic break here going on. We can also use ranges, multiple values, and even we can use operators. For example, in this case, asking about the data type of something. Else, it's what we are used to as default on other languages. Okay, it's just that, and you get used to that. It's not a big deal. Loops.
And it goes through all of them, right? So it can go through multiple cases, right?
Good question. So what if you want to go with multiple cases? By default, it's not going through multiple cases, okay? Because they realized when they created Kotlin, the language, that most of the time we are using the switch, or in this case the when, for exclusive options. But if you want, you can request a fall through. So it's the other way around. Instead of breaking, you are going to say that you want to continue on the next one. Okay, and in that case, you use fall through. So you can request explicitly that you want to move to the next case. Okay. Loops, we have the standard while, so it's just a while, as you know. Okay, don't do this at home, but while true. And the for, we only have for in as an option. If you want to use the old for I equals 0, I less than I plus plus, you can use ranges like this. A range is like some kind of a literal collection on the fly. Okay, it's not exactly a collection, but it seems like that here. Okay, so in this case, 0 to 10 without 10. Okay, so this will print 10, 0 to 10, to 9. Sorry, 0 to 9. Okay, simple. So that's simple. Variables and types. So now I'm opening this lesson 2 that we have here. Okay, remember, KTS is just this simple way that we have to see some Kotlin code. We can execute this code, but without attaching this to an actual app. Okay, that's kind of the idea. This is not an app. We are not building an app. We are just playing with Kotlin, and for that we use this KTS file format that we'll never see again. We will never see this format again later. Okay, All the files will be just KT. That's the extension for Kotlin. So we mentioned that it's an statically typed language. So actually every variable will have a type. So in this case, data will have a type even if I don't see explicitly any type. If you hover with your cursor, you will see there that it says integer is really small, okay, but let me see if I can zoom in a little bit, like so. So you can see it says that data is an int. So it's actually using, it's actually inferring the type based on the value that I'm setting. But if I want to, I can use colon and the type, such as int, capital I, because it's a data type. Okay? So be careful if you're coming from other languages where int is with lowercase I. So this is a mutable variable. We use var for a variable. Okay? But we also have immutable variables with the keyword val, from value, val, not var. By the way, do you know the difference between an immutable variable and a constant? Does anyone know the difference between?
Compiler type, compiler time.
Compiling time. It has to do with that, exactly. A constant value, it's something that needs to be defined at compilation time. When you're compiling the app, the value must be set. That's a constant. An immutable variable, it's a variable, so it's actually a place in memory when you're executing the app. But the idea is that once you set a value, it's immutable, so you cannot change that. So for example, in Kotlin, we have both constant and immutable variables. Typically, we use immutable variables. Immutable variables can be set with values coming from a database, from the network, from what the user is typing. A constant, no. A constant must be set at compilation time. So a constant, it's actually const_val. That's how you set that. And we don't have global constants. They must be part of a structure, such as an object or a class. We don't know what that object is. Give me a minute. Okay? So have in mind that. So if you're coming from other languages, val is like let in Swift, is like const in JavaScript. Okay? But here is val. Then types. As I mentioned before, we use colon. Okay, but if not, they are inferred. Similar to other languages with type inference, we might have problems. For example, we have a price that is a double. Other price, it's also a double because I'm setting a value, even if I'm not explicitly saying double. But sometimes we want a double, but we are getting an integer. That's because 23 is an integer. Well, we can solve the problem with .0. In that case, it's a value. It's a double. So a .0 will force a double. Also, you can force explicitly the type. In case you have this ambiguity, you can resolve those ambiguities by defining the type. A double is by default a double precision float. We also have the type float, and there is an f that we can add here to explicitly say that we don't want a double, we want a lower precision float. Okay, we don't going to use this a lot actually. Okay, but have in mind it's there. We have a structural equality, that's double equals, and triple equals is referential equality. So the first one is actually like executing the equals method of that object to see if the contents are equal. For example, two strings will give me true, but will give me false on referential equality because I'm actually making two objects. Okay, so this is true because they have the same value, and this is false because they're different objects. Every time you create a literal string, it's actually a different object in memory. Okay, similar to what you have on other languages. It's similar to JavaScript. It's not the same, but similar to the idea in JavaScript. Core data types: strings, characters is char, int, double, boolean, and we have any. We don't typically use any a lot, but any means, well, in this variable, I can hold any kind of object. And then you need to cast or ask for a type before actually using it. Okay? As I mentioned, we have float. Also for integers, we have bytes, shorts, and longs. So integer is actually goes between short and long in terms of how many bits it's using. We use double quotes for strings. Okay. We also have a way to create a multi-line string using triple double quotes. Okay, and this is multi-line, and the multi-line will let you. It's actually pretty good, for example, for JSON, because now you don't need to escape the quotes. Okay, so something like that. On every string, we have template expressions. Template expressions are using the $sign when it's just the name of a variable, or we use the $sign and a code block for a more complex expression, and it's going to make a replacement automatically on that string. So that's pretty straightforward and easy to use, similar to JavaScript in that case. Collections. So Kotlin includes several collections ready to use, as we expect from a modern language. So we're not going to cover all of them. So let's cover quickly the ones that we will use during the rest of the day. We have lists. A list is what we typically know as an array, okay? But here we have the type list. We define the type with angle brackets. Okay, this is actually a generic, in case you know what a generic is. So we define an array of countries or a list of strings. And unfortunately, if you're used to JSON, we don't use that syntax for literals. We use a constructor that has the name list of. So list of, it's actually like in JavaScript, opening square brackets and setting the countries. Okay, like this. But here we use list of. It's a constructor, it's a global constructor that returns a list of the objects that you have. Okay, by default, a list is immutable. So after I set the list, I cannot remove or add variables and types. So I'm not. It's time to write some Kotlin code. So that's up to the basics of the Android operating system and the architecture of our apps. But let's jump directly into code, into Kotlin code. So Kotlin it's a language created by JetBrains. It's time to write some Kotlin code. So in T files, KTS, what's that? The S is from Scratch. A Kotlin Scratch file. You will get some PNG that we will use in a couple of minutes. And also, you will get into a Kotlin 101 folder. What we're going to do now is to open Android Studio into that folder. It's not actually an Android project. This is actually a couple of files with the extension KTS. By the way, Kotlin files are KT files. KTS, what's that? The S is from Scratch. A Kotlin Scratch file. What's a Scratch file? It's actually a file to play with Kotlin without actually making an app. Okay, that's kind of the idea. You can open that, by the way, if you want in VS Code or any other IDE that you want. In this example only. For Android development, we will actually need Android Studio. But for these files, you can open this in Android Studio if you want. It's just to see and play with Kotlin. In Android Studio, you can open and then you go directly into the folder. In this case, I have it into Assets, Android, Kotlin 101. It will look like this. So you have a list of files, and then with the tip of the day that I don't want, and then the code on the other side. So here we're going to just see some code, and also if you want, you can run Kotlin code. That is like a playground. It's a place to play with Kotlin without actually making an app. Okay. So basic expressions. Kotlin code looks like JavaScript or any modern language when you first see it. So if I throw you some Kotlin code, you will understand most of it without even doing any explanation. So I will just jump directly into the differences and really quickly over the things that are usual or similar to other languages. So Kotlin looks like any other language. For example, semicolons. Semicolons are there, but they are optional. And I can say that 99% of the time, you're not going to use semicolons. You use semicolons only when you have two expressions, two sentences in the same line. And that's not something you want to do, actually. Okay?